This video might take this lesson might take 2 days. We'll see. We shall see. But this is what we have here. And please, on the chat, make sure that you add your answer and stuff like that, so I know that everybody with me. Is this graph proportional? Well, proportional means it's a straight line, and proportional means it goes through 0, 0. Does it go through 0, 0? Mm-hmm. Is it a straight line? Mm-hmm. So is it proportional? Mm-hmm. Wow. Super laggy. What is the slope? Well, I know it's a positive slope. And according to the picture that I have over here, it looks like I go up 2 over 3, up 2 over 3, up 2. So slope is rise over run. Slope is rise over run. My rise is 2. My run is 3. My slope is 2 over 3. Closing a few of these tabs here so that I don't have so much lag. This is very laggy. What is the equation? Well, remember, slopes of proportional lines, or equations of proportional lines, are in the form y equals mx. I now know what my m is. My m is 2/3. So I'm going to rewrite this out as y equals 2/3 2/3 x. Wow, it's not even letting me write a 3. This is going to be fun. Let's close out a few more things. All right, what are we doing today that's so important? We are going to learn slope-intercept form. Slope-intercept form is one of the most important things you will ever learn in math, ever. Okay? Here it is right off the bat. Slope-intercept form is a way of writing an equation, and that equation will give you the slope and the y-intercept. You know what the slope is. The slope is the rise over run. The slope is a number that tells you how steep my line is. If my slope is 1/2, then my rise is 1, my run is 2. Here's a new word, y-intercept. What does y-intercept mean? Y-intercept is the point that your line is going to cross the y-axis. It's the point where your line is going to cross the y-axis. Slope is a number that gives you how steep it is. Y-intercept is a number that tells you where on the vertical line your line's going to go through. Okay, most importantly, slope-intercept form is given to us by the equation y equals mx plus b. So when y is all by itself, so if you remember from chapter 1, where I made everybody do all these problems where we had to get y all by itself. You had to get y all by itself. Why did Mr. Perich make us do all of those? Because in slope-intercept form, y is all by itself. Now notice in slope-intercept form, the x part comes first. So if you're wondering, well, why did Mr. Perich always make us put the x first? This is why. Because of slope-intercept form. So when y is all by itself, the number in front of x is the slope, and the number floating around all by itself is the y-intercept. Okay? So, again, let me write out y slope-intercept right here. Y equals mx plus b when y is all by itself, the number in front of x is the slope, and the number floating around all by itself is the y-intercept. So look at problem 1. Is y all by itself? Yup. Which means the number in front of x is the slope. So my slope is negative 4 over 5. And the number floating around all by itself, which is not 2, but negative 2, is the y-intercept. That's it. Problem 2. When y is all by itself, the number in front of x is the slope, and the number floating around all by itself is the y-intercept. Is x all by itself? Yup. So the number in front of x is the slope. So I'm going to put negative, not 7, even though the answer is negative 7. I'm going to put negative 7 over 1 because I want to view slope as rise over run. So anytime today that I see a slope, if it's not over a number, I'm going to put it over 1. Every time, every time, every time, every time. So you're going to see me do that again in problem 3. The y-intercept is the number floating around all by itself, which is positive 12. That plus sign means it's a positive number, positive 12. Is y all by itself for problem 3? Yup. So the number in front of x is the slope, which is positive 4, or for the slope, I want to put 4 over 1 because I'm thinking rise over run. And the number floating around all by itself is the y-intercept. So life is great. Life is great when y is all by itself. It's wonderful. What if y is not all by itself, though? Oh, boy. Oh, boy. Well, all of these, y is either not all by itself or it's just in reverse order or something weird like that. Look at problem 4. Let me remind you that what colors did I use? Green, blue, red. So I'm going to write it out the same way. Slope-intercept form is y equals mx plus b, where m is the slope, the number in front of x is the slope, and the number floating around all by itself is the y-intercept. Is 4, problem 4, in slope-intercept form? No, it's not. But it's not that bad. Y is all by itself. It is. But what I want to do is I want to, instead of having 11 plus 1.5x, that's a positive 1.5x. I'm allowed to just switch it. They're both positive, so I'm allowed to just go, whoop. So 1.5x plus 11. Is y all by itself? Yup. So the number in front of x is the slope. Now 1.5, if I were to turn that into a fraction, would be 3 over 2. So I'm actually going to put 3 over 2 for my slope instead of 1.5 because why not? Why the heck not? Is y all by itself? Yup. Then the number floating around all by itself, positive 11, is the y-intercept. It's me giving you a thumbs up. Problem 5, is y all by itself? No. In fact, it's y minus 3.5. So I have to get rid of minus 3.5 by doing the opposite of minus 3.5, which is plus 3.5 to both sides. When I add 3.5 to both sides, that crosses out. Bring down the y. Bring down the equals. Do negative 2x and positive 3.5 combine? No, because one has an x and the other one doesn't. So I'm going to first write out the negative 2x because it's slope-intercept. And then I'm going to write out the positive 3.5. Is y all by itself now? Yup. So the number in front of x is my slope. The number in front of x is my slope. So it's negative 2, but I'm going to write out negative 2 over 1. And since y is all by itself, the number floating around, 3.5, is my y-intercept. Another thumbs up for you kids. Play your cards right, you might get double thumbs up. Is y all by itself for 6? No. How do I get y all by itself? Well, I do the opposite of minus 6 because minus 6 is what's in the way, and I add 6. I add 6 to both sides. That leaves me with y equals 3 over 8x plus 6. Now, why didn't I combine them? Because you have an x and you don't. Why did I put the 3 over 8x first? Because you always put the x part first. Always. Is y all by itself now? So the number in front of x is your slope, and the number in front of my x is 3 over 8. And my y-intercept is going to be the number floating around all by itself, which is 6. So that is how you find the slope and the y-intercept. 1 through 3 were easy because y was already by itself. 4 through 6 was not because it wasn't in slope-intercept form. What we're going to talk about is the most important part, and that's about graphing. Okay, graphing is a 5-step process. And if I were you, I would grab some graph paper and get ready to follow along. But we're about to graph a bunch of equations. Very, very, very important. If you're thinking, but we already graphed in section 1, we made a table. We made 3 different types of tables. I know, but this is faster, a lot faster. Okay, step 1 of graphing is you're going to put your equation in slope-intercept form. Step 2 is you identify the slope and the y-intercept. Step 3, you put a point on the y-axis for the y-intercept. Step 4, use the slope, which is the rise over run, to make more points. And step 5, connect the dots. Let's actually see a problem in action.
All right, graphing linear equations. We are to graph that equation there. Luckily, this guy right here is in slope-intercept form. Remember, if y is all by itself, the number in front of x is our slope. The number floating around is our y-intercept. So the number floating around -5 is where we begin. We put a dot right there at -5 on the y-axis. Since that's a negative slope and it's rise over run, we go up 1, left 3, negative slope, up 1, left 3. If we run out of room, we can go down 1, right 3, down 1, right 3. And I like to make as many dots as I can. Take a ruler, draw yourself a line, bang, bang. That, ladies and gentlemen, is our answer.
So let me go back.
Bang.
And kind of backtrack just for a second.
That, ladies and gentlemen.
Before I moved it up, before my hands moved it up. Perfect. No. My first step was make sure it's in slope-intercept form. Slope-intercept form is when y is all by itself. Look, y is all by itself. So it was in slope-intercept form. Step 2 is identify the slope and the y-intercept. That's what we did for the first 6 problems. The slope, and you can't see it well, but the slope here is -1 over 3, and the y-intercept is -5. So step 3 was put a dot on the y-axis for -5. So I don't want to do that. So I go, oh, I should play it in slow motion. No. Well, no. I put a dot at -5, and then my slope tells me where I go from there. So my slope is negative 1 over 3. A negative slope goes up and to the left or down and to the right. So I could go up 1, left 3. So I did. I went up 1, left 3, put a dot. Up 1, left 3, put a dot. Oh no, I ran out of room. So I go back to my original dot. And instead of going up 1, left 3, I can go down 1, left 3, right 3. I'm sorry. Down 1, right 3, put a dot. Down 1, right 3, put a dot. And then draw your line with step 5. So here we go. And what we're going to do is we're just going to do problem after problem after problem after problem after problem after problem after problem until we run out of time. Make sure you're paying attention. Step 1. Make sure your equation is in slope-intercept form. It is. How do I know that? Because y is all by itself, and it looks like that. Step 2, identify your slope and your y-intercept. When y is all by itself, the number in front of x is your slope. So 1 over 4, positive 1 over 4 is my slope. And the number floating around, negative 1, is my y-intercept. Step 3, go to your y-axis and put a dot on the number where your y-intercept is. So since my y-intercept is negative 1, I'm going to go to the y-axis and go to negative 1 on the y-axis and put a dot right there. Step 4, use your slope to make more dots. This is a positive slope. Remember, slope is always rise over run. Slope is always rise over run. Slope is always rise over run. Since this is a positive slope, it goes that way. So I'm going to rise 1. I'm going to go up 1, right 4. Up 1, right 4. So let's do that. I'm going to go to my blue dot, and I'm going to go up 1, right 1, 2, 3, 4, and put a dot. Go up 1, right 1, 2, 3, 4. Oh, I ran out of room. So I'm going to go back, and I'm going to go down 1, left 1, 2, 3, 4, and put a dot. Remember, up and to the right is the same as down and to the left. So I can go up 1, right 4, or down 1, left 4. Down 1, left 4 means down 1, left 1, 2, 3. Uh-oh, I don't have enough room. But that's okay. I only need 2 good dots to make a line. And in this case, I have 3. So what I'm going to do is I'm going to connect these dots. Step 5 was connect the dots and make sure it's a straight line. Notice that my line covers the entire coordinate plane. I don't cut my line short because I only have 3 dots. I don't just go from dot to dot and connect the dots like I'm playing some kind of coloring book game. That's what it looks like. Okay. So again, one more time, in review, to make sure we're all good, what I did is I noticed that I have an equation in slope-intercept form. I already have it. Y is already by itself. So the number in front of x is my slope. The number floating around is my y-intercept. I start out by putting that y-intercept, or putting the dot on that y-intercept. So I put a dot at negative 1. I put a dot at negative 1. Then I use my slope to make more dots. So if my slope is 1 over 4, I can go up 1, right 4. So I did. Up 1, right 1, 2, 3, 4, put dot, up 1, right 1, 2, 3, 4, ran out of room. But if I wanted to put a dot like right there, I could, and my line would go through it anyway. So, we would be all right. Easy peasy. And since I ran out of room on the right side, what I can do is I can go back here and say, well, I ran out of room and I want to make more dots. So instead of going up 1, right 4, I can go down 1, left 4, and it creates a straight line. If for some reason you put a dot somewhere else, and if you're accidentally going backwards and you put a dot somewhere else, and your line is no longer a straight line, you did it wrong, because your lines are supposed to always be straight lines. So, if you have 3 dots and you take a ruler and you connect the dots and the dots don't create a straight line, you did something wrong. Let's do another. Step 1. Write out your equation in slope-intercept form. It is. Oh no, there's no number in front of x. Sure there is. Let me rewrite it out and show you. How many x's do you see there? 1. So if it's negative, then you have negative 1x plus 2. If you don't have a number in front of x, it's going to be 1. If you don't have a number in front of x, it's going to be 1. Going to be 1. Obi-Wan. Obi-Wan Kenobi, Star Wars. Is y all by itself now? Yeah. What's the number in front of x? Negative 1. But you know what? I want to view slope as rise over run. So I'm not going to call my slope negative 1. I'm going to call it negative 1 over 1. Remember, if you only have a number, just a regular number, not a fraction, you can turn it into a fraction by putting it over 1. Is my y all by itself? Yeah. Then what's my y-intercept? The number that's floating around is positive 2, so my y-intercept is positive 2. Put a dot on the y-axis for where your y-intercept will be. So put a dot at the y-axis at 2. So there's my dot. That's step 3. Step 4 says, use your slope to make more dots. Now, my slope is negative, which means it's going to go that way. So slope means rise over run. So what's negative 1 over 1 look like? Up 1, left 1, up 1, left 1, up 1, left 1. So go to that blue dot over there and go up 1, left 1, put a dot. 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 I ran out of room. That's okay. I know what's going to happen. If I can go that way, then I can go that way. So up 1, left 1 is the same as down 1, right 1. Down 1, right 1. Ha! You know what it is. Down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Ooh, I hope Wiz Khalifa doesn't see this video and try suing me. Wiz Khalifa. He's from Pittsburgh. Well, I have all those dots. What should I do with them? How about I connect them? Lit job, fam. I don't know what that means. I just saw it on the internet once. I think it means good. Ooh, very lit job indeed. Let's do another. Is y all by itself? Yes. But I don't have a number in front of x. Oh, yeah, invisible 1. So when y is all by itself, the number in front of x is my slope. Instead of putting 1, I'm going to go 1 over 1. When y is all by itself, the number over here floating around is my y-intercept, which is just 1. So yeah, they're both 1s. Who cares? So that was step 1. This was step 2. Step 3 is go to your y-axis and put a dot on the 1. So here's my y-axis. I'm going to put a dot on the 1. Step 4 says take that slope and use that slope to make more points. Remember, positive slope goes up and to the right. So this slope means up 1, right 1, up 1, right 1. Ha! You know what it is. Up 1, right 1, 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 up 1, right 1. Huh? Let's go in the other direction. Down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. Huh? Huh? Look at all them dots. Let's connect them. Ooh, I'm going to create a math rap name, and instead of Wiz Khalifa, it's going to be Wiz Collect Them. Instead of Wiz Khalifa, it's going to be Wiz Connect Them. And I'm going to sing songs about up 1, right 1. It's a shame that I don't have yellow here. I mean, I could, but it's all right. Beggars can't be choosers. Step 1, is y all by itself? Yes. Step 2, if y is all by itself, identify the slope. The slope is the number in front of x. The slope is 4 over 3. The y-intercept is the number floating around all by itself. The y-intercept is -4. Step 3, put a dot on the y-axis for your y-intercept. Here's my y-axis. My y-intercept is -4. Go down to -4 on your y-axis. Put a dot there. Step 4, use your slope to make more dots. This is a positive slope, which means up and to the right. Up 4, right 3, up. So go to my blue dot, up 1, 2, 3, 4, right 1, 2, 3. Put a dot. Up 1, 2, 3, 4, right 1, 2, 3. Put a dot. Up 1, 2, 3. I ran out of room. Go back to your blue dot. Remember, up 4, right 3 is the same as down 4, left 3. So down 1, 2, 3, I ran out of room. So I have 3 dots, and that's all I need. I actually only need 2, but I'm making 3, and I'm going to use the best of my 3. Once you have your dots, connect them. Whiz connect them. Work hard, play hard, work hard, play hard. Work, 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 work. That's another Wiz Khalifa song. Oh boy, he's definitely going to sue me now. I hope he doesn't. He and I started a huge Twitter beef a couple years ago because he heard me doing videos like this, and I don't need the trouble. I don't need the trouble, Wiz. I don't need the trouble. 9 minutes? 9 minutes. Let's keep going, baby. Why stop now? This is weird. Is this in Slope-Intercept form? Well, y is all by itself, so yeah, I guess. So the number in front of x is my slope. Well, there is no x. There's no x at all. So I guess there's 0 slope. The number floating around all by itself is the y-intercept. So if the y-intercept is 4, go to your y-axis and put a dot at 4. And I remember from the other day that if a slope is 0, it's completely flat. It's completely horizontal. So there's my 0 slope. Look, y is 4, and over here y is 4, and over there y is 4, and over here y is 4, and y is always going to be 4. Should we stop? No. Poop. And I hate using that language, but I did it anyway. Is y all by itself? No. What is in the way? Well, that 4x is in the way. I have to get y all by itself. So for the first time in doing these problems, y is not all by itself. How do I get y all by itself? Subtract 4x from both sides. Subtract 4x from both sides. Cross u out. Y equals. What's 0 minus 4x? Well, minus 4x. If I wanted to put plus 0, I could, but I won't. Is y all by itself now? The number in front of x is my slope, so negative 4 is my slope, but I'm going to write out negative 4 over 1 because slope is rise over run. And the number floating around is my y-intercept. I don't have a number floating around. Where is it? ¿Dónde está? ¿Dónde está mi el number? I forgot number. Well, there is none. So it's 0. Oh, I remember. Y equals negative 4x. That's proportional, which means it's going to go through 0, 0. Ugh, silly me. I'm going to put a dot at that 0 right there. Remember, when your y-intercept is 0, you go to your y-axis and you put a dot at that 0, and you use this slope to determine more points. So my slope is negative 4 over 1. So a negative slope goes up and to the left, up 4, left 1, up 1, 2, 3, 4, left 1, put a dot there. Up 1, 2, 3. Oh no, ran out of room. Go back to your original dot. Up 4, left 1 is the same as down 1, 2, 3, 4, right 1. Put a dot there. Down 1, 2, 3. Ran out of room. I have 3 dots. Connect them, if you will. Magnifique. Four minutes. Might have time for one more. Is y all by itself? No. What is in the way? I have an x floating around. So let's get rid of that x that's floating around. Minus x. Minus x. Cross u out. Do negative 3 and negative x combined. No. Y equals negative x minus 3. There's no number floating in front of x. Oh, that's right. It's an invisible 1. Y equals negative 1x minus 3. What's my slope? My slope is negative 1. What's my y-intercept? My y-intercept is negative 3. Where do I put my dot first? You know what? Let me turn my slope into negative 1 over 1 because it looks better. Where do I put my dot first? Put it at negative 3. Go to the y-axis. Put a dot at negative 3. There it is. Dot's at negative 3. My slope is negative 1 over 1. So what would Wiz California say? What would Wiz California say? Up 1, left 1, 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 up 1, left 1. Uh-oh, I ran out of room. Down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Let me get my marker and draw a line. Let me get a marker and draw a line. And as you get the hang of these, you can do them that fast. All right. So I had a few more. Oh, actually, I only had one more. So we did fine. We did fine, but I'm calling it quits for the day. I think we did enough.